Alright, should be a video in process. I sort of have to check. Yeah, it looks like it's working. Alright, it's probably going to be a Ken Wheeler video. Well, I already know that it's going to be the Ken Wheeler video. So I did a couple of videos on these pyramid magnets. He really doesn't understand anything about magnets, so I thought I would do a description of how it actually works. Sorry about the terrible frame rate. Apparently having both cameras isn't working out too well, so I have to come up with another strategy. But anyway, the sound's adequate, so who cares? So I don't know if I need to play this stuff. Maybe I'll play some of it after I do the explaining. Yeah, might work better that way. Alright, so the idea is you have a pyramid magnet and you're going to in some way amplify the power of a magnet by having the magnet in a pyramidal form. Okay, and somehow this little tip would be a 1 millimeter. So just for the sake of a quick argument, Ken Wheeler doesn't really prove anything or do reasonable scientific experiments. And what he really should do is demonstrate. If he's going to claim something's the most powerful magnet for its size, they should demonstrate with some sort of evidence. So what he should do is connect a little piece of steel and try two different lengths, like one that's long and one that's short. Okay, so a little short one, a little flat one, and a little long one. Just glue it to a string, some mechanism, a little bit of fishing line, put it across a couple of pulleys, and then you can just tie a weight to it, kilograms, and try two different magnets. So try the pyramid version, and then try the exact same n, n equals n values for the height and of the magnet. So you use the same thickness of magnet, the same n values, and see which one the 1 millimeter piece of metal sticks to better. So yes, tie this down so the magnet can't move, and see how much weight you have to put on to pull off the piece of metal. And that'll tell you whether this magnet is stronger or not. So that's the experiment he should do to demonstrate how much stronger his magnet is. Now the trick is that the only extra strength it can have is really close to the surface. So Ken Wheeler, as stated, really doesn't understand anything about how magnets really work. So the trick is, you have to understand the magnet is basically made up of two fields, right? The South Pole and the North Pole, and they're different. And so in a, by comparison to a traditional square magnet, let's put this in. You might be able to kind of understand what sort of is happening. So in a magnet, the field energy, the force, the whatever you want to call it, radiates in all directions from the two poles, but it also radiates in these kind of directions. So from every point it radiates. So there's lines going in all these directions in terms of force, bits of energy. So the light isn't just being, or the magnet isn't just being shot out this way and isn't looping around. Like I said, the field lines are completely an illusion. So the trick is, you can sort of understand that, I think you'll be able to understand, that if you have a pyramid shape, the ability for there to be lines going, say if we had the regular square magnet, you could kind of understand that there would be lines of force going this way, and this way, and this way, and there'd be lines going this way, and this way. Those lines aren't there now because of this pyramid shape. So you've gotten rid of some of the force lines. They can't go at these angles because you've sort of eliminated the possibility of those angles. And what that means to some other magnet you place in the field, right, that you're gonna sense the strength of this magnet with, the trick is going to be is that this blue one is going to repel this blue one. And so if it's a regular magnet, you can sort of understand. Just draw it in here quickly, just for the sake of clarity. You can sort of understand that these blue lines are going at these angles in will be able to hit this blue magnet, and they're going to be repulsive. So there's not going to be just the attractive force between the blue and the orange. There's going to be some repulsive force to the blue, on the blue. And so some of the pulling energy is going to be diminished by the fact that there's going to be this repulsive energy. And the closer this magnet gets to the surface, you can sort of understand if the magnet's right on the surface, then those lines become less relevant, because they can't get to as much stuff. But they're also closer, so in some respects it probably evens out. I can't say for sure, but anyway. So the idea would be is that with a pyramid magnet, you kind of take away this part of the magnet, the repulsive part. So you kind of make that moot when you're really close. When you're not close, it's not going to matter as much, because then you can still get the energy from the side of the magnet. So, but the distance is greater, and the further the distance is, that means you have a weaker field, because this attraction is going to be fairly weak because of the longer distance. So you're not going to be gaining anything. See, in a regular magnet, you're gaining an awful lot. The further away you go, you at least gain all these side lines. And so you're keeping some of your strength, where in the pyramid, the strength of the magnet is going to diminish much more rapidly, like twice as fast, because you've eliminated all this extra pulling force. You've doubled the distance between it and the pulling force, and by doubling the distance, you've 4 times weakened the strength of the attraction. So the point would be is that right on the surface, okay, this is going to be kind of effective, because you're basically just eliminating the ability for any of the repulsive force to get to this north side of the magnet, the north repelling the north. You've sort of eliminated that as being effective. So so you might have a tiny bit increase at the peak. But again, it hasn't been demonstrated. I mean, all they do is measure it with a Gauss meter and say so, and the Gauss meter is right on the tip. So they haven't really done anything but acknowledge what I just said, which is you might have a slight advantage. So they really need to do is a pull test with a magnet as small as this little peak, and just to put it on the 2 magnets and pull the 2 apart with that, and you'll be able to find out how much stronger this magnet is. And I would claim it's not any stronger by any significant amount. And it's, Ken Wheeler just doesn't really know what he's talking about, plain and simple. He doesn't, I'll play some of his videos, just, it's all Ken Wheeler jargon. So maybe if I close this, the frame rate on the other camera will get better, maybe. Well, doesn't look like it. Alright, so this one, he doesn't really say anything except it's the most powerful magnet in the world. It's the most powerful magnet. Doesn't give us any of his wacky theory. Thank you, YouTube. You could play the video now. Good. It's alright with me if you play the video. It's doing this a lot to me. Just, decides to, I'm not going to play it.
Before looking at the larger one over here, the really powerful one, let's take a look at a different type of pyramidal array. This one actually is a 1/2 inch thick. It's still 2 by 2 at the base, and it also tapers to 1 inch with a 1 inch.
So he begged people to buy these magnets for him, you know, hundreds of dollars worth of this pyramid magnets. So again, the tiny little surface here, little whatever it is, a couple of millimeters, some kind of bullshit like that. And so that's what he should get, a surface that small. So either another little magnet or just a piece of steel that size. Glue the piece of steel to some sort of fishing line, some sort of cable. Put a couple of pulleys and put a weight on them and test how much weight it takes to pull the magnets apart. And it'd be a good test to see if you have gained anything from this whole nonsense.
Base that tapers to 3 millimeters, but as you can see, it's a lot.
Alright, on the other video, yeah, he does say some funny things. Okay, so he does say you can feel it. So he puts it on his nose. He doesn't do it on the video, but he says, I can feel it on his lips or his nose. He can feel how strong the magnet is. Not exactly a very scientific experiment. Alright, so let's just jump ahead a little.
Plane of inertia.
So he's measuring the plane of inertia, as he calls it, which is really the what do they call that? I forget what they call it. It's just where the two magnets separate. You know, from the North Pole to the South Pole, there's a line created. Obvious, kind of, you can just intuitively kind of figure that out. That there's, you know, red light coming out of one side and blue light coming out of the other side. And there's a line where, you know, it's just going to be blue and red. And he's saying it's curved. Well, it's curved partly because he doesn't have this. Obviously, he can't press his magnetic film into the magnet, so he's measuring it at different distances. It's right touching the magnet here at the corners, and it's like a centimeter away from the magnet here. That's why it ends up being a curved line. This is just another ferrocell illusion. Has nothing to do with the reality. So he just he knows nothing about mechanical things. Just mechanically.
You see, the actual field geometry of the magnetism on this is actually as if there was on the plane of inertia is depressed like a bowl formation.
A bowl formation. It's a bowl formation. No, nothing like that happens.
At the center. Also, too.
All right, so here's the ferrocell, which I've already demonstrated. These are just a bunch of lines that intersect in the center, and so they all come out of the center, and they're just 2 lines per LED. So for every LED light you have, you end up with a line. Pretty simple. So this light strip he has here must have a bunch of little discrete LEDs in it. A whole bunch of them.
This one underneath the supercell, it's actually quite interesting.
So a completely meaningless pattern. It's just a complete distortion of what the actual little iron bits are doing in the ferrofluid. The iron bits are lining up in basically straight to the magnet. So the reason why it looks square is because they're doing more straightness here than being radial like they would for a circle. For a circle, it would look like a sun radiating, just lines all radiating from this center. Because it's square, there's more lines going straight back and forth here. So that's why these lines are squared. And that's it. It's completely unremarkable. So the image doesn't demonstrate anything about this particular triangle magnet at all.
And then what I'll do is I'll grab the powerful beast, and then I'll bring it over here. Let me actually, first let me put it on its tip, and if you actually place it on its tip, it doesn't look any much dissimilar. Wait till I change positions, however, from any other. There we go. Any other magnets, that looks the same.
Well, you can't see it very well, but obviously the lines are more curved because he's further away from the magnetic field because you can't get to it really. That's why it's all kind of weak. And so it's strong in the center and everything else is nothing. So, but the lines are just basically, all the little iron filings are just basically lining up in a radial pattern.
It's hard to get focus on this. But you'll notice
exactly what you would expect if you had iron filings and a north face of the magnet sticking up. Exactly the same pattern you get with the iron filings, just what you're getting with the ferrofluid, and it's just a distortion of optics because of the fact that the ferrofluid refracts light that hits it at specific angles, and that's all it is. So at specific angles, the light is reflected, and there's just nothing remarkable about the supercell.
a distinct difference at the point of centipedal inertia and acceleration on the side profile. And by the way, the side profile in this
centipedal inertia, just jargon, just absolute mush. So he's got three magnets stuck together. Now the trick is that you know magnets do add to each other, but the trick is they don't do it very well. So you lose some of the power of the magnet because it can't basically split in half here and have a perfect line of inertia, or whatever he calls it. So it still has, each individual magnet still has a north and south pole, and it's still just a combination of magnets. And it would be better to make one solid magnet than to stack three magnets. You'll get you'll get more value, more magnetism, okay, out of the magnet.
Looks the same, except it's more pronounced when and the plane of inertia right here.
So again, the magnet will attempt to orient to the configuration. You've stacked three magnets, so the middle magnet will still have a middle, and that middle will be more dominant than the other middles on the other magnets. But that's all that's going to happen. Nothing miraculous. Nothing to see here, really. All right, see what other claims he makes.
Bottom. What if I could actually, I can't tilt this up on its bottoms. Up on its top, but you just see this. But
well, you really probably should be able to, but whatever.
Portal for.
I mean, if it's supposed to be so powerful at the tip, you would think you would be able to stand it up on its tip quite easily.
Dielectric portal, if you will. You could call it a few different things.
Yeah, dielectric portal. I mean, how could that mean something to any rational person on Earth?
Is increased at the base, and it's just simplex pressure mediation.
Simplex pressure mediation. Simplex pressure mediation. I mean, simplex pressure mediation. I'm mediating the pressure simplexly. That's how a magnet works. It's just doing this. I'm a magnet. I'm pressure mediating. Yeah. I'm hyperbertoloiding and troyoiding also, but I mostly do pressure mediation. Yeah, I don't think so.
You can actually see the size of it.
No, you can't see anything. And whatever you're seeing has nothing to do with reality. It really doesn't. It's an illusion. It's an optical mirage, and that's all it is. It doesn't have anything really to do with exactly how the little bits are actually lined up.
And the distortion from the constructive and destructive interference around it.
So he just throws these words in. Like I said, this is something jargon he came up with like 6 months ago. He started with this destructive and constructive interference, as if this pattern has anything to do with that. Again, if you used one LED, there'd just be two little lines of light. Two little lines perpendicular to the LED. That's all there would be. Where's the constructive and destructive interference? It's just all just babble. He's just such a snake oiler. Preaching just garbage.
Is actually real, because it is real when it comes to pressure mediation like this.
Yeah, nothing. It's not real at all. Let's see what he was saying was real.
Can't stand New Age stuff. If that offends you, so what? I can't stand New Age stuff, but this is... And
that's all you are, is New Age crap. So he's got another video on magnetizing seeds, and again, more just pseudoscience. He doesn't do a controlled experiment. He just says, I think they taste better. Oh, is it that scientific?
Time you could actually say pyramid power is actually real, because it is real when it comes to pressure mediation like this. We actually have as a conjugate.
See, so he should just demonstrate that it's real. Again, I'm not even arguing that there can be no change. I'm just arguing that theoretically it can't be much. You can't be gaining much because the only thing you're gaining is you're getting rid of a little bit of the repulsive energy. So the attraction should be a little bit stronger right on the surface, but it would only work right on the surface. As soon as you go a little bit of distance away from the pyramid, you're losing so much of the magnet. You've thrown away half of your magnet. Obviously, the further away you go, you've weakened the field substantially.
Of the point source of the magnetism, what actually defines a magnet.
So point source is a nice concept, and that's sort of what I was talking about when you have a surface. And you could argue that the stuff coming off the surface is radiating off a million zillion little points, and it's radiating in all directions off a million zillion little points. And some of that is true for how magnets work.
Since it's not quantitative, it's qualitative. The qualitative definition.
No, it's quantitative. That's why they have n numbers. That's why they have all these rules. That's why there's a, I think it's the r cubed rule of dipole degradation.
Of a magnet is a point source emission with a geomagnetic precession.
The geomagnetic precession, which doesn't mean anything. Geomagnetic. Some kind of maybe round magnet precession thingy. No evidence of any of that going on at all. Nothing ever demonstrated in the history of mankind called the geoprecession associated with a magnet. This complete crap.
Point source in the whole that defines the qualitative nature of a magnet. And we have point source specifically, which is, now the first point source is incommensurable. And
incommensurable. I mean, how can this mean anything to anybody?
Has actually no location, since obviously you could...
No location. It doesn't, the points are in a source, but they have no location. I'm a point with no location. Sourcing. But yeah, I do sort of have a location. You can see it with the bad frame rate that I'm always somewhere, aren't I? Oh, yeah.
Slice a magnet like a hunk of salami, a million slices. If you could do that, of course you can't, but if you could, each slice would have a quote-unquote North Pole and a South Pole. So,
yes, but that's exactly what the magnet is made up of. It's a bunch of atoms in alignment that are basically the definition of what a magnet is. It's a bunch of dipoles stacked on top of each other. Every magnet is basically a bunch of atomic magnets stacked on top of each other. So, of course, when you cut it somewhere, you're going to get the north and south poles again. Because you can't cut and the line of inertia of the atom. You can't cut the atoms in half. Jeez.
The one point source in the magnet is incommensurable, but the second point source is not incommensurable, but because its location, the topos, is right here.
Yeah, its location, the topos is right here. Yeah, there's no whatever. There's no point source by his description, right? So now he's turned point source to a location. So somehow there's one point source somewhere in this magnet.
Here. And if you actually wanted to say magnetism, laser, this would actually be the closest analog. That's what is the difference between a light and a laser.
So again, there's absolutely no evidence that as soon as you get off this little tiny peak, as soon as you're one tiny little shred of distance away from it, you start losing power. You'll have less pull than you have if you just had a rectangular magnet. As soon as you get just a hair, just the thickness of a piece of paper off of this surface, you're already going to start getting less magnetism, not more.
Would be the closest analog that I could think that people could wrap their minds around as far as what defines this being the single.
There's no focusing, so it looks like a funnel, right? So that's the idea, right? It looks like it's a funnel and it's funneling the magnetism. No, you just took away a big hunk of the magnet. You cut it out. You don't have it. But there's no funneling. Nothing's getting funneled through the little point. So the little point is the only part of the magnet that has the true full thickness of the magnet. That's the only part that's the full thickness of the magnet. The rest of the magnet gets thinner and thinner and thinner. So you can just sort of understand my magnet that was this big is getting smaller and smaller and smaller. And the further you go away from the magnet, the more you're going to realize how much of the magnet is missing.
Most powerful magnets for its size and volume on Earth.
So claims that just say nothing. Most powerful magnet. Well, as long as you're on the very tip of that 1 millimeter surface, and as long as you're right on it. Because as soon as you're a paper's thickness away, it's all of a sudden the worst buy in magnets you could possibly buy. It's just a shitty magnet.
This one I'm got right here. I'm trying to back my video device away so I don't ruin it. And here you can see the...
Says more... Ooh. Yeah, sure can. He has all these cameras, and yet he doesn't seem to be able to, have a setup where he can just do his macro stuff automatically, efficiently.
Pyramidal magnet. So actually this is the first video of its kind ever done by anybody, ever.
Just the more amazing nonsense. So why don't you get a magnet, shaped like a horse's ass? And then you can say, look, I made the first video of a magnet shaped like a horse's ass.
Actually, the guy that actually sells these pyramidal magnets has never even heard of a ferrocell or a supercell. Never heard of it.
Yeah, and he's fine without it because it's not a scientific instrument. It has absolutely no value except for as a toy, as something to entertain people who want to see swirly lines, because it doesn't reveal any truth about the actual mechanics of a magnet. Now, if you were studying optics and refraction, it might be a very good tool to understand all this angular stuff and how there's certain angles and then you get a full reflection, and other angles and you get no reflection, and all that's very interesting science, but you're not doing any of that. So you're again, you're just using the wrong tool for the wrong job.
Not really into magnetism, nor does he know anything about it, but that's not an insult. That's just...
You're the one who's clueless, Ken. Clueless.
That describes everybody. So, there we go. Here's the world's first view underneath a supercell viewing device of the world's most powerful permanent magnet for its size and volume.
Again, just more crap. Prove it. Demonstrate it with an actual experiment that demonstrates it. Yeah, because it's just not true.
And here you can see...
I mean, especially the size and volume thing, because these are like N44 magnets or something. They're not like the strongest N value magnets, so it wouldn't even be true anyway.
This is, I don't know if that was anticlimactic or not, but this is what a lot of people had asked me for. God!
Yeah, well, I imagine the people who paid for it should expect a little better than this. Oh, so I paid all that money so you could do this? How fascinating. Not.
This sucker's powerful. Did you see the magnet? There's a piece of metal underneath this table. I put the magnet over there and went, chop! It's so powerful! Thank you so much for watching. If you like these videos.
Yes, and even if he had no pyramid on here, and he just had this 2-inch by 2-inch neodymium magnet, it would have done exactly the same thing. Totally unremarkable.
You can click the link below. Tell me to jump off a cliff, whatever makes you happy. And...
grow some integrity. And grow some balls. And, I'll debate you on your knowledge of magnets and how they function. Maybe we can do some competing experiments. So why don't you just once in a while try to demonstrate what you claim with something called evidence? Yeah, that would be something new for you. Alright, so enough of a video, I think. And so we'll call it a good enough. So I will continue to struggle with finding a way on this computer to get Linux to give me a decent video frame rate. It works not bad. Like I said, my old computer has a better video card. No problem. Pretty good. This computer that I want to use, meh, shit. So anyway, till the next time, I have to hit my key shortcut, and so till next time.